Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter chemical and ionic equilibrium. So any doubts if you have in any steps, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that 3 moles of PCl5, 3 moles of PCl3 and 2 moles of Cl2 are taken in a vessel if at equilibrium the vessel has 1.5 moles of PCl5. The number of moles of PCl3 present in it is. So PCl5 will undergo decomposition reaction. PCl5 is a gas. It will convert into PCl3 gas plus Cl2 gas. So it is a reversible reaction, which is, so PCl5 will decompose into these two products. So it is a decomposition reaction. So here 3 mole, so at T equal to 0 means initially 3 moles of PCl5 is taken and 3 moles of PCl3 is taken and 2 moles of Cl2 is taken in a closed vessel. Then at equilibrium, at, at equilibrium it is told the vessel has 1.5 moles of PCl5. It means that 1.5 moles has reacted. So it will form 1.5 mole of PCl3. So it will form, so at equilibrium I will have 3 plus 1.5 moles of PCl3 and also 2 plus 1.5 moles of Cl2. Since why 1 mole of PCl5 will give 1 mole of PCl3 and 1 mole of Cl2. So 1.5 moles of PCl5 has decomposed. So I will get 1.5 mole of PCl3 and 1.5 mole of Cl2. So it means at equilibrium the number of moles of PCl3 that is present is 4.5 moles. So option B is the correct answer. Well, here it is told for the reaction 2HI goes to H2 plus I2 minus Q kilojoule. So it means that it is an endothermic reaction. It means that it will absorb Q kilojoule amount of heat. And here it is told the equilibrium constant depends upon. The equilibrium constant depends upon. So okay, so it is an endothermic reaction. Endothermic reaction. So as we know that the equilibrium constant for an exothermic reaction for, for the equilibrium constant for an exothermic reaction, uh, which means that where the uh, where heat is released, the equilibrium constant for exothermic reaction decreases with increase in temperature. With increase in temperature, and the equilibrium constant for an endothermic reaction increases with temperature. Increases with temperature. With increase in temperature. So it means that the equilibrium constant will depend on temperature. So option C is the correct answer. Then here it is told N2 plus 3H2 gives 2NH3, 2NH3 plus heat. Now, what is the effect of the increase of temperature on the equilibrium of the reaction? What is the effect of the increase of temperature on the equilibrium of the reaction? The effect of increase in increase of temperature on the equilibrium of the reaction. So here it is an exothermic reaction. Exothermic reaction. So so as heat, so as the temperature increases, the equilibrium constant K decreases. The equilibrium constant Kc that decreases since it is an exothermic reaction. So it means when temperature increases, Kc decreases. So it means that now Qc will be greater than Kc. So if Qc is greater than Kc, so it means there will be a backward shift. There will be a backward shift of in there will be a backward shift in the equilibrium. So the equilibrium will shift backwards. It means the equilibrium is shifted towards the left. So option C is the correct answer. QC means reaction quotient. So since the equilibrium constant decreases, so the reaction quotient will be higher than the uh, the equilibrium constant. So there is a backward shift in the equilibrium. And here it is told 5 moles of SO2 and 5 moles of O2 are allowed to react. At equilibrium, it was found that 60% of SO2 is used up. If the partial pressure of the equilibrium mixture is 1 atmosphere, the partial pressure of O2 is. So here SO2 plus O2 will give me SO3. Two SO2 plus O2 will give me 2 SO3, and all are gases. So at T equal to 0, initially 5 moles of SO2 is used with, and, and 5 moles of O2 is taken. And at equilibrium, it is found that 60% of SO2 is used up. So it means that 0.6 times 5, so 60% of 5 mole, that is 3 moles has been used up. So we have 2 moles at equilibrium. So here now, so 3 moles of SO2, so 2 moles of SO2 will react with 1 mole of O2. So it means 3 moles of SO2, 3 moles of SO2 will react with 3 by 2 moles of O2. 3 moles of SO2 has reacted. So a 3 mole of SO2 will react with 3 by 2 mole of O2. So 3 by 2 mole of O2 will react. So 5 minus 3 by 2, that is, was at 10. So 7 by 2 mole of O2 will remain. And here also 3 mole of, so here initially 0 moles of SO3 was there. So at equilibrium, 3 moles of SO3 will be formed. So now the total pressure at equilibrium, the so here it should not be partial pressure, it should be the total pressure of the equilibrium mixture is 1 atmosphere. The total pressure at equilibrium is told that is 1 atmosphere. So the partial pressure of oxygen, that will be equal to the mole fraction of oxygen in the mixture times the total pressure of the equilibrium, the total pressure of the equilibrium mixture. So now the partial pressure, now the mole fraction of oxygen in the mixture, that will be equal to 7 by 2 divided by 2 plus 3 plus 7 by 2. It means the number of moles of O2 divided by the total number of moles of the mixture. So that will be 3.5 divided by 3.5, 2 3 are 6, yeah, 3.5 plus 5, that is 8.5. It is 35 by 85, so I can say it is 5 7s are 35, 5 1s are 5, 5 7s are 35. So it is 7 by 17. So therefore, the partial pressure of oxygen in the equilibrium mixture, so that is mole fraction of oxygen times the total pressure of the equilibrium mixture, so which is 1 atmosphere. So it is 7 by 17 times 1 atmosphere. So that will be equal to 7 by 17 atmosphere. 7 by 17 atmosphere. So that will be equal to 17 0.70 divided by 17. So that will be 17 for the 68. So 20. So that is 17 1s are 17, then 30. 17 2s are 34. So it is approximately 0.41. Okay. 0.41. Okay. It is 0.41 atmosphere approx. It means option C is the correct answer. Then it is told 2HI gives H2 plus I2. The equilibrium constant of the above reaction is 6.4 at the equilibrium constant at 300 Kelvin, that is equal to 6.4. And if 0.25 mole of H2 and I2 are added to the system, the equilibrium constant will be. Now, so if the concentration, if the number of moles of the products are increased, then also the equilibrium constant will remain unchanged, since the temperature is not changed. Since why the rule is that the value of the equilibrium constant Kc remains unchanged on changing the concentrations of the reactants or products. Concentrations of the reactants or products. So it means the equilibrium constant will remain as 6.4 only. So option D is the correct answer. Then here it is told 30 centimeter cube. 30 cc means cubic centimeter. So 30 centimeter cube of 1 by 3 molar HCl and 20 centimeter cube of 1 by 2 molar HNO3 and 40 centimeter cube of 1 by 4 molar NaOH solutions are mixed. So they are mixed and the volume was made up to, so the net final volume, that is 1 decimeter cube, or I can say 1 liter. So then the pH of the resulting solution will be. So now the number of moles of H plus N, that will be equal to, so 30 centimeter cube, so that is 30 ml I can say. So that is 30 by 1000 liter times 1 by 3, this much moles. So that will be 0.01 mole plus, so it is the H plus which is obtained from HCl, plus we have to add, the number of moles of H plus which is obtained from HNO3. So that is 20 by 1000 into 1 by 2 minus, since why here we have OH minus, we have hydroxide ions, so it is a base, so it will reduce the amount of H plus ions. So that will be equal to 40 centimeter cube, so that is 40 by 100, no, 40 by 1000 times 1 by 4. So these many moles. Since why the number of moles we can find by using molarity into volume in liters. Now 1 centimeter cube, as you know, that is equal to 1 by 1000 liter. Since by 1 centimeter cube, I can say it is 1 ml also, 1 milliliter also. So this will come to 10. Okay, so this will be 0.01 plus 0.01 minus 0.01. So which will be equal to 0.01 moles. Now therefore, the pH of the resulting solution, that is equal to minus log of the concentration of H plus N. So now concentration of H plus N, that will be equal to the molar concentration. It means the number of moles of H plus N divided by the net final volume of the solution. So that will be 0.01 moles by 1. So this much mole per liter. So therefore, the pH value, that will be equal to minus of log of concentration of H plus, that is log of concentration of H plus, which is 10 power minus 2. So which will be equal to 2. So the pH is equal to 2. So option A is the correct answer. Now it is told 10 power minus 6 molar NaOH is diluted 100 times. The pH of the diluted base is, it is diluted 100 times. Now therefore, initially we can say the concentration of OH minus ions is same as the concentration of NaOH, which is obtained from okay. So it is the concentration of NaOH is same as concentration of hydroxide ions. So that will be equal to 10 power minus 6 molar. And finally, dilution, after the dilution, so here the concentration of OH minus ions, so that will be equal to 10 power minus 6 molar divided by 100, so which is 10 power minus 8 molar. Now here, the rule is that since the hydroxide ion concentration is less than 10 power minus 6, so or okay, so yeah, so the concentration of OH minus ions, which is obtained from the hydrolysis of, which is obtained from the autoprotolysis of water, from the autoprotolysis of water should also be considered. Should also be considered. So now, the so the net hydroxide ion concentration, that will be equal to 10 power minus 8 plus 10 power minus 7. Since why it is obtained from the autoprotolysis of water. So it means I can say that will be approximately be 10. So this will be 10 into 10 power minus 8. So 10 plus 1, that is 11, 11 into 10 power minus 8. This is hydroxide ion concentration. So from here we can find out POH. POH, that is equal to 14 minus pH. Now that will be equal to minus log of concentration of OH minus 1. So therefore 14 minus pH, we have to find out the pH of this diluted base will lie in between which range, in between which values it will lie. So that will 14 minus pH, that is equal to minus log of hydroxide ion concentration, that is 10 power minus 8 into 11. So therefore it will be 14 minus pH, that is equal to 8 minus log 11. Now log 11 I can take it approximately 1 also. It is slightly more than 1. So therefore the value of pH, that is equal to 14 minus 8 plus log of 11. So that is 6 plus log 11. Now log 11, actually I can say this will be 10 into 10 power minus 8. Okay. Log 11 is slightly more than 1. Log 11 is more than log 10, obviously, which is log 10 is 1. So it means that 6 plus log 11 will be slightly more than 7. So the value of pH will be more than 7, slightly more than 7. So it will lie in between 7 and 8. The pH value will lie in between 7 and 8. So option D is the correct answer. Then it is told, consider the following gaseous equilibria with equilibrium constants K1 and K2 respectively. Then the equilibrium constants are related as. So for the first one, we have SO2 plus half O2, that gives that SO2 plus half O2, that gives SO3 gas. Okay. So now, therefore, here the equilibrium constant told is K1. So therefore, K1 I can say that will be equal to the concentration of SO3 divided by concentration of SO2 into concentration of O2 whole power half. And then 2SO3 gives 2SO2 plus O2. So here the equilibrium constant is K2. So this K2 I can write concentration of SO2 whole square into concentration of O2 divided by concentration of SO3 whole square. So that will be equal to, so now if we take the square of K1, so K1 square, that will be equal to SO3 whole square divided by SO2 whole square into concentration of O2. So which is nothing but 1 by K2. So K1 square equal to 1 by K2. So option A is the correct answer. Then it is told 0.023 gram of sodium metal is reacted with 100 centimeter cube of water. The pH of the resulting solution is. Now, when sodium reacts with water, then what will form? Then it will form, um, then it will react with the hydroxide and it will form NaOH plus it will give H plus. Yeah. Therefore, so from 1 mole of sodium, 1 mole of NaOH will be formed. So now therefore 0.023 gram of sodium, that is equal to 0.023 gram divided by the molar mass of sodium, which is 23 gram. So this much of sodium. So it means that it is 0.001 mole. So these many moles of sodium. So that reacts with 100 centimeter cube of water. So therefore, from 0.001 mole of sodium, I will get 0.001 mole of NaOH also. So therefore, the molarity or molarity of NaOH, molarity of NaOH, which will be same as the concentration of hydroxide ion. So that will be equal to the number of moles of NaOH, that is 0.001, divided by the number of moles divided by the volume, the net the net volume of the solution, which is 100 ml, 100 centimeter cube. So I can say it is 100 by 1000 liters. So which is into 10, that will go up. So it will be 0.01, 0.01 molar, or I can say mole per liter. So therefore this I can write it as 10 power minus 2 also. Now the pH of the resulting solution. So pH of the resulting solution, that is okay. So which is, so from here POH we can find first. POH, that is minus log of concentration of hydroxide ion, that is minus log of 10 power minus 2. So that is equal to 2. So POH is 2, and then pH we have to find. Therefore pH is equal to 14 minus POH. So that is equal to 14 minus 2, that is equal to 12. So it means option D is the correct answer, that the pH of this solution is 12. Then here it is told a buffer solution contains, there is a buffer solution which contains, okay, here we have 0.1 mole of sodium acetate, means CH3CONA, sodium acetate, in 100 centimeter, means 1000 centimeter cube. So in 1000 ml of 0.1 molar acetic acid, CH3COH. So it means a weak acid with its salt with a strong base. So it is an acidic buffer. So it is an acidic buffer. Now to the above buffer solution, 0.1 mole of sodium acetate is further added and dissolved. The pH of the resulting buffer is always equal to, the pH of the resulting buffer is equal to, So now, therefore, the pH of an acidic buffer, how to find acidic buffer, that is equal to given as, that will be equal to pKa of the weak acid plus log of concentration of the basic salt of the weak acid, basic salt of the weak acid divided by the concentration of the weak acid. So therefore that will be equal to pKa plus log of concentration of basic salt plus log of concentration of basic salt the weak acids. So that will be equal to 0.1 mole, and the volume is 1 liter only, 1 liter. So the molarity of the acetic acid, or the molarity of the salt, or the concentration of the salt, that will be equal to 0.1 mole. I can say here 0.1 mole of sodium acetate is further added. So it means the net number of moles now is 0.2 moles. So it means it will be 0.2 mole divided by 1 liter, since 1000 ml is 1 liter. So this is 0.2 molar. The concentration of the salt is 0.2 molar divided by concentration of the weak acid, that is 0.1 by 1 molar. So this will be equal to pKa plus log. So here actually, so it will be, yeah, pKa plus log 2. pH will be equal to pKa plus log 2. So option D is the correct answer. Then here it is told that 1 decimeter cube solution, it contains 10 power minus 5 moles each of chloridans and chromatans, CrO4 2 minus ions. So then this 1 decimeter cube solution is then treated with, so this is treated with 10 power minus 4 moles of silver nitrate, 10 power minus 4 moles of silver nitrate, so it is AgNO3. So then which of the following observations is made? Which of the following observations is made? So now here AgNO3, AgNO3 can react with Cl minus ions, or AgNO3 can react with chromatans, CrO4 minus ions, CrO4 2 minus ions. So here it will form AgCl plus NO3 minus ion, and here it will also form, okay, so it is a reversible reaction, okay. So here, okay, it is a precipitation reaction. So here also it will form Ag2C2, Ag2CrO4 plus here 2NO3 minus ions. Now here the thing is, here these two are insoluble, or I can say sparingly soluble salt, AgCl and Ag2CrO4. Their Ksp values are being told, so it means they are sparingly soluble salt. So here precipitate can be formed. So we have to find if precipitation occurs or not. So the rule is the rule for precipitation to happen, that is if the ionic product, that is KIP, that is more than KSP, which is the solubility product, um, then only precipitation will take place. Then only precipitation takes place. And if the ionic product, if the ionic product, which is KIP, that is less than KSP, then precipitation does not occur. Precipitation does not take place. So now the ionic product for so here we have 10 power minus 5 moles and 1 decimeter cube, it means 1 liter solution is there. So therefore now the concentration of Cl minus ions, that is equal to 10 power minus 5 molar, and the concentration of CrO4 2 minus ions, that is also 10 power minus 5 molar, and the concentration of silver ions, that is Ag plus ions, that is also 10 power minus 4 molar. Okay. So now, therefore, the ionic product KIP for AgCl here in this case, so that is the concentration of Ag plus into concentration of Cl minus. That will be equal to Ag plus concentration is 10 power minus 4 into Cl minus concentration is 10 power minus 5. So that is 10 power minus 9. Now that is obviously, now KSP for AgCl is 10 power minus 10. So this is more than 10 power minus 10, which is the KSP for AgCl. So KIP for AgCl is more than KSP for AgCl. So precipitation of AgCl will take place or will happen. It means silver chloride gets precipitated, and KIP for Ag2C2RO4, Ag2CRO4, so that will be equal to the concentration of Ag plus whole square into CrO4 2 minus concentration. So that will be equal to Ag plus concentration is 10 power minus 4 whole square into, that is 10 power minus 5. So it will be, what is the 8 plus 5, that is 10 power minus 13, which is less than 10 power minus 12 into 4, which is the KSP for silver chromate, Ag2CrO4. So it means precipitation of Ag2CrO4 means silver chromate will not happen. Precipitation of silver chromate will not happen, but uh, precipitation of silver chloride will happen first. So silver chloride gets precipitated first. So option C is the correct answer. Now it is here, it is told pH value of which one of the following is not equal to 1. pH value of which one of the following is not equal to 1. pH value of which one of the following is not equal to 1. Okay. So therefore the pH value of HNO3, that will be equal to same as the that will be equal to minus of log of concentration of H plus. So now here H plus and concentration for HNO3 will be same as the concentration of HNO3 only, which is 0.1 molar. So which will be minus log of 10 power minus 1 10 power minus 1. So it will be equal to, so it will be equal to 1. So now here pH of HNO3 that will be equal to 1 here. And here it is told that pH of which one is not equal to 1. Now pH value of H to 4 that will be equal to minus log of concentration of H plus ion. Now the concentration of H plus ion for H to 4 that will be equal to uh, twice of the concentration of H to 4. Since why it will, since 1 mole of H to 4 will give 2 moles of H plus ion. So that will be 2 times of 0.05 molar, that is 0.1 molar. So that will be also equal to 1. And similarly, pH of the mixture in the part D, pH of the mixture in part D, that will be equal to minus log of concentration of H plus. So here H plus and concentration in the fourth part, that will be equal to 50 centimeter cube, that is so M1 V1, so 0.4 into 50 plus, so minus 0.2 into 50 divided by the number of millimoles it will give. So 50 by 1000, since 50 ml means 50 centimeter cube means 50 ml, so by 100 centimeter cube by 1000 ml, so this much mole per liter. So this will be equal to, the 1000 I can cancel out, so this will be 50 into 0.2 divided by 100, so 52, so this is also 0.1 molar. So here also it will come 1. And in case of part C, the pH value of CH3COH, so that will not be 1. Since why? Here the concentration of H plus ion, that is not equal to the concentration of CH3COH. Since why? CH3COH is not a strong acid, so it is a weak acid. So pH value of a weak acid, so here we have to find by using pH will be equal to uh, half of pKa minus log C. For weak acid, we have to find using half pKa minus log C, since since it is a weak acid. So here the pH of CaCOH will be not equal to minus of log of it will be equal to minus log of concentration of H plus, but here concentration of H plus will be much lesser than the concentration of CaCOH. So the pH value will be slightly, it will be more than 1. It will be more than 1. So option C is the correct answer, since here the pH is not equal to 1. Then here it is told H2S is passed into 1 decimeter cube of a solution containing, so here you have a solution containing 0.1 mole of zinc ion Zn2 plus and 0.01 mole of Cu2 plus ion. And here H2S gas is passed into 1 decimeter cube into, here I have 1 liter or 1 decimeter cube of the solution. So it is the required volume of the solution here. H2S gas is passed through it, and 0.01 mole of Cu2 plus till the sulfide ion concentration reaches. The sulfide ion concentration is reaching 8.1 into 10 power minus 19 moles. Okay, which one of the following statements is true? KSP of Zn and Cus are these and these respectively. So which one will precipitate? So here also, as we know that if the ionic product, if the ionic product of the sparingly soluble salt, that is KIP, if that is more than the solubility product, is more than the solubility product, which is KSP for the sparingly soluble salt like ZNS and CUS, then only precipitation will take place. Then only precipitation will occur. Precipitation will occur, else precipitation will not occur. So now, so here the concentration of Zn2 plus, that is equal to 0.1 mole divided by 1 liter, so that is 0.1 molar, and concentration of Cu2 plus, that is also equal to 0.01 molar, and concentration of sulfide ion, that is equal to 8.1 into 10 power minus 19 molar. So now, therefore, for ZNS, now here it is given that the KSP for ZNS, that is 3 into 10 power minus 22, and KSP for Cu2S, CUS, that is equal to 8 into 10 power minus 36. Now, the ionic product for ZNS, that is equal to the concentration of Zn2 plus into concentration of sulfide ion. So that will be equal to concentration of Zn2 plus is 0.1 10 power minus 1 into concentration of sulfide, that is 8.1 into 10 power minus 19. So that will be 8.1 into 10 power minus 20, which is obviously more than 3 into 10 power minus 22, which is the KSP for ZNS. So here for ZNS, KIP is more than KSP. So it means the precipitation of ZNS will happen. Precipitation of zinc sulfide will occur. And for copper sulfide, which is KIP for CUS, that will be equal to concentration of Cu2 plus into concentration of sulfide ion. So that will be equal to concentration of Cu2 plus, that is 10 power minus 2, 0.01 into 8.1 into 10 power minus 19. So that is equal to 8.1 into 10 power minus 21, which is obviously much higher than 8 into 10 power minus 36, which is the KSP for copper sulfide. So therefore, here also the precipitation of copper sulfide will also occur. Will also occur. Will also occur. So it means option B is the correct answer, that both CuS and ZnS will precipitate. So both will precipitate. Option B is the correct answer. Then here it is told at 300 Kelvin, a gaseous reaction A goes from B to C. Hmm. Goes from B to C was found to follow first order kinetics. So it happens at 300 Kelvin. Starting with pure A, the total pressure at the end of 20 minutes was 10 millimeter, was 100 millimeter of mercury. The total pressure after the completion of the reaction is 180 millimeter of mercury Hg. The partial pressure of A in millimeter of Hg is, so let's suppose the initial at t equal to 0, the initial pressure at t equal to 0 was P naught, and the initial pressures of B and C will be 0 only, since B and C was not formed initially. Then at t equal to 20 minutes, here some fraction of A will react, so it will P naught minus P will be there, and P is will be the partial pressure for B, and P is the partial pressure of C. Here all are gases, since why here it is also told that it is a gaseous reaction. So now therefore after 20 minutes, the total pressure that is equal to P naught minus P plus P plus P, that is equal to P naught plus P, that is equal to 100 millimeter of Hg. Hg means mercury. Okay. Then the total pressure after the completion of the reaction. So when the reaction completes, after completion, after completion of the reaction, here A will fully react, A will completely react. So uh, so here in, so finally it will be 0, and here P naught and here P naught. So therefore the total pressure after completion, after completion, that will be equal to 2 P naught, and that is equal to 180 mm of Hg, 180 millimeter of Hg. So it means P naught will be equal to 90 millimeter of Hg. Now the partial pressure of A is how much? The partial pressure of A. So we have to find the partial pressure of A at 20 minutes. So at t equal to 20 minutes, we have to find the partial pressure of A. So the partial pressure of A, that will be equal to P naught minus P. So that will be equal to, so from here we can say P naught is 90, so 90 plus P is equal to 100. So it means that P will be equal to 100 minus 90, that is equal to 10 mm of Hg. So that will, so P naught is 90 now minus 10, this much mm of Hg, that is 80 mm of Hg. So 80 mm of Hg is the partial pressure of A at t equal to 20 minutes. So option D is the correct answer. Then here it is told 2 moles of N2O4 is kept in a closed container at 298 Kelvin. N2O4, 2 moles of this is kept in a closed container at 298 Kelvin and at and 1 atmosphere pressure. Okay. Then it is heated to 596 Kelvin when 20% by mass of N2O4 decomposes to NO2. The resulting pressure is. So here 2 moles of N2O4 was initially taken and then it was heated. Then it was heated to 596 Kelvin. So it will decompose into 2NO2. So at T equal to 0, 2 moles were taken. Then at equilibrium, we can say some moles will react, let's say X moles reacted, and then 2X moles of NO2 will be formed. So now it is told that 20% by mass of N2O4 reacts. The resulting pressure is. Okay. So now, therefore, so the initial mass of N2O4 that is taken, that is equal to 2 moles, 2 moles into the molar mass of N2O4. So that will be equal to 2 into 14 to the 28 plus 16 for the 64. That will be equal to 2 into 4 plus 8, 12, 6 plus 2, 8, 92. Okay, so that will be 2 to the 4, 2 9 18, 184 gram. 184 gram of N2O4 was initially taken, and then how much part has reacted? So the mass of N2O4 that decomposes to NO2, that decomposes, that will be equal to 20% of 184 gram. So that is 0.2 into 184. That will be equal to 2 4 the 8. Okay, 0.2 into 0.2 into 184. That will be equal to 2 4 the 8 to the 16 2 3. Okay, so 36.8 gram. 36.8 gram has reacted. Now, therefore, 36.8 gram of N2O4, it means that it is 36.8 divided by 92 moles. That is equal to 4 to the 8, 4 9 the 36. So it is 0.4 moles. 0.4 moles has reacted. So it means therefore X is equal to 0.4 actually. So therefore 2X will be 0.8. So it means 0.8 moles of NO2 has been formed. Now here, so here also if the initial pressure was 2P and initially no moles of NO2 was found. So then since the temperature has increased to twice the initial value, so I can say P is means uh, the pressure is proportional to T. Since it is kept in a closed container, so the volume will be kept constant. Okay. So since the temperature has increased to twice, since the T final equals to twice of the T initial, so the final pressure also will be twice of the initial pressure. So here So it means the final pressure will be 2 atmosphere actually. Final pressure will be 2 atmosphere. So now, therefore, the resulting pressure, therefore now the total pressure that will be equal to the total number of moles. Now, okay. So at equilibrium, 2p minus, okay, from 2 moles. So, okay, okay. So here 0.4 moles has reacted and 0.8 moles of NO2 has been formed. So now, therefore, the final value of total number of moles, that will be equal to 2 minus 0.4 plus 0.8, that is equal to 2 plus 0.4, that is equal to 2.4. 2.4. Now, okay. So here I think this concept is not proper. Okay. So here so that concept was wrong actually. So here we know that the total pressure that will be equal to the total number of moles, or I can yeah. Okay, so the volume is kept constant, PV equals to nRT. So when when the temperature increases, then only it decomposes. The N2O4 will decompose to form NO2. So the volume will be constant since why it is in a closed container, and the temperature will be also constant. So the pressure is proportional to the number of moles. So now the pressure, initial pressure is 2 atmosphere. Since why the temperature, okay, the temperature has increased to twice the initial value. So the initial pressure is 2 atmosphere, and then the temperature remains constant at 596 Kelvin. That will remain constant only. And so now the pressure will be proportional to the number of moles. So now the initial pressure is 2 atmosphere when the initial number of moles was 2 moles. So now when the final and, and now when the final number of moles is 2.4, the final total pressure that will be also equal to 2.4 atmosphere. Since why P is proportional to N when the temperature is kept constant. So therefore I can say P initial by N initial, that will be equal to P final by N final. So P initial is 2 atmosphere by the initial number of moles was also 2 moles, and the final pressure we have to find by the final number of moles, which is 2.4. So it means if we solve it, then we will get P final as 2.4 atmosphere. Okay, so it means that option A is the correct answer. Okay, then here it is told that the pH of a solution obtained by mixing 100 ml of a solution of pH equal to 3. pH equal to 3, we have, uh, so it is pH equal to 3, it is a solution, 100 ml of this solution, uh, it is mixed with a 400 ml of a solution, 400 ml of a pH equal to 4, pH equal to 4 solution. Then the resultant pH will be how much? So from here, the H plus ion concentration, that is equal to 10 power minus 3 molar, and from here the H plus ion concentration, that is equal to 10 power minus 4 molar. So now, therefore, the okay. So now the total number of moles of H plus ion that will be obtained, that is 100 ml. So it will be M1 into V1. So that is 10 power minus 3 into 0.1 liter, I can say this will be. And this is also 400 ml means 0.4 liter. So that is plus 0.4 into 10 power minus 4. So this will be 10 power minus 4 plus 0.4 into 10 power minus 4. That is 1.4 into 10 power minus 4 moles. So now, therefore, the total volume, the total volume that will be equal to 500 ml, 500 ml, which is 0.5 liter. Now, therefore, the resultant concentration of H plus, therefore, the resultant concentration of H plus ion, that will be equal to the number of moles of H plus divided by the net volume, which is 0.5 liter. So that will be equal to 1.4 into 10 power minus 4 moles divided by 0.5 molar, that will be equal to 14 by 5 into 10 power minus 4 molar. Now therefore the pH of the mixture solution, that will be equal to minus log of concentration of H plus ion, that will be equal to minus of log of 14 by 5 into 10 power minus 4. So that will be equal to 4 minus log of 14 by 5, or I can say 2.8, 4 minus log of 2.8. So option C is the correct answer. Then here it is told that 5 liter of 0.4 normal NaOH, 5 ml of 0.4 normal, or I can say this is 0.4 molar NaOH. Since why, as we know, normality equals to the molarity times the valency factor, Now, since from NaOH I can obtain one hydroxyl ion only. So it means here the valency factor for NaOH will be 1 only. So it means for NaOH the normality and the molarity will be same. Similarly for HCl also, 1 mole of HCl will only give me 1 mole of hydroxide ion. No, 1 mole of H plus ion. So its valency factor is also 1. So the normality of HCl will be same as the molarity of HCl. So therefore here, so therefore here, 5 5 ml of 0.4 molar NaOH is mixed with 20 ml of 0.1 molar HCl. 0.1 molar HCl. 0.1 normal HCl is same as 0.1 molar HCl. Now, therefore, the number of moles of H plus N, so that will be equal to the here M1 V1, which is 0.1 into 0.02 liter, minus this is 0.4 into 0.005. So this much moles, and the total volume, the total volume of the mixture, that is equal to 25 ml, which means 0.025 liters. So this will be equal to 0.002 minus 4 5s are 20. This will be 0.1234, 0.0020. So this is also 0.002 moles. So therefore it is 0 moles. It means the number of H plus ion is 0. So therefore the H plus ion concentration that is coming 0 only. H plus ion concentration that is coming 0. So it means that it is, so we have to take only, so it is the neutral solution. It is neutral solution, since why, the number of moles of H plus which is obtained by mixing NaOH and HCl, that is coming 0. It means that only we should take the H plus ion which is coming from the water itself. So it is obtained from the neutral solution. So H plus ion concentration will be 10 power minus 7 only. So the pH will be equal to 7, which is for a neutral solution. So option B is the correct answer. Since here what is happening, this amount of NaOH is completely neutralizing this amount of HCl. So the H plus ion which is obtained from the water only, that only we have to consider. So pH will be 7, since it is a neutral solution.